This is Unit 1, the Alphabet Grammar of Geometry, Lesson 1.5, Algebra Review. This class, make sure you get date, time, and location that you're watching this video. Parent, guardian, sign off. Yes, you are in geometry class, but to be successful in this geometry class, there are 3 very essential basic skills, math skills, that you need to have to be successful in this class. 1, you need to be comfortable doing longhand computational math. You should not be touching a calculator for doing basic single, double-digit multiplication, addition, subtraction. Get in the habit of doing that longhand. It's good for the brain. It connects neurons. 2, you need to be comfortable solving for unknowns. 3, you need to be comfortable adding, subtracting, simplifying, multiplying, and dividing radicals. If you don't recognize the word radical, it means square root. So we're going to go 3 cycles, 1 each. We're going to do an example of this, an example of this, an example of this. After each example, you're going to be expected to do some of this math on your own. So longhand computational math, yes, we're going back to 2nd grade. A couple things I recommend is that you use physical arrows to keep track of stuff. So just work this with me. Another thing is, you auditory students, you should be talking your math out loud. So let me demonstrate that. 3 times 9. Notice I drew an arrow to help keep my eyeballs keep track. 3 times 9, 27. Write down the 7, carry the 2. 3 times 2, 6, plus 2, 8. And 3 times 7, 21. Bring down the 0. 4 times 9, 36. 6, carry the 3. 4 times 2 is 8, plus 3, 11. 4 times 7 is 28, plus 1 is 29. Now when you add, physically draw these lines so you can keep your eyeballs straight. That's 7. 14, carry the 1. It's going to be 3. 11, carry the 1, 3, 31,347. So, a couple suggestions. 1, for you verbal students, say your computations out loud. Also, I recommend many of you physically draw little arrows so you can keep track of what you're multiplying. When you're adding, draw the little lines so that your eyeballs don't get lost, etc. Couple other things about computations. I want to talk about canceling. When you're on the same side of the equal sign, so notice we have a couple fractions here we're multiplying, and we're on one side of the equal sign, the same side of the equal sign. You can cancel to your heart's content here. Okay, because we're on one side of the equal sign. So technically, we just multiply top and bottom. So I'm going to just connect those so you can see they go together. So now cancel everything out that you can on one side of the equal sign. So 3 goes in there 3 times, 3 goes in there twice, and I can do this. 4 goes in there 3 times, and whoa, lo and behold, we can do this as well. 3 goes into 3, and you are left with 1/2. Okay, so when you're on the same side of the equal sign, you can cancel to your heart's content. When you are on opposite sides of the equal sign, you cannot do this. What I just did was wrong. That's why it's in red. 3 goes in there 3 times, 3 goes in there 4 times. You cannot cross an equal sign and cancel stuff out. I call that stealing from your neighbor. You have you're here, there's your neighbor's backyard, you got the fence between you. You can't cross your neighbor's fence and start taking stuff away from them. But you can be a very nice neighbor And you can multiply. Now watch what I do here. I'm going to go 12 times 9. Miss Way, why didn't I actually multiply 12 times 9? The key to multiplying is not multiplying. It's factoring. So just write it 12 times 9 and leave it. Equals, multiply 4 times x. So when we solve, we're just going to get rid of this 4 here. And this is why I didn't multiply, because it's easier to factor. 4 goes in there 3 times. We look at what's left. 3 times 9, so x equals 27. So when you're on one side of the equal sign, cancel to your heart's content if you're multiplying. If you're crossing an equal sign, you must cross multiply. You cannot cross cancel across an equal sign. Some of you, it's been forever since you've divided fractions. So you need to remember this one simple concept. Dividing by the fraction is exactly the same as multiplying by the reciprocal. So 5/9 divided by 10/12 is exactly the same thing as 5/9 times the reciprocal, 12 over 10. We're going to solve. We're on one side of the equal sign, so we can cancel to our heart's delight. 5 goes into 10 twice. 3 goes in here 3 times. 3 goes in there 4 times. We can still cancel stuff out. 2 goes into 4 twice. So we look at what's left. I have a 2 and a 3. And that final answer is therefore going to be 2/3. So remember, dividing by the fraction is the same as multiplying by the reciprocal. Adding and subtracting fractions. Do not freak out with fractions. The simplest thing you need to do is find the lowest common denominator. Find what both of these go into. And the simplest way is actually just to multiply it. So I'm going to do 7 times 2. Now watch how I do this. I have little shortcuts here. All right, so I'm going to put 14 here. Why don't you try this? See if it works for you. Ready? I call it arrow in, arrow out. Arrow in. 7 goes into 14 twice. Arrow out. Little baby 2 there, 2 times 5, and that's going to change to a 10 over 14. See, arrow in, arrow out. I even use 2 different colors so I can keep track of this. Arrow in, 2 goes into 14 7 times, arrow out. Little baby 7 there, 7 times 1, that is 7 over 14. Now that your denominators are exactly the same, you simply add the numerators. Final answer, 7 over 14. All right, let's try another one. Four and 6. I try to find the lowest common denominator they both go into, and if you can't find one, you just multiply them straight out, but I know easily 4 and 6 both go into 12. So I'm going to go arrow in, arrow out. Ready? Follow with me. 4 goes into 12 3 times, arrow out. I bring the little baby 3 there, 3 times 3, 9 over 12. Arrow in, arrow out. 6 goes into 12 twice. So I bring my little 2 over. 2 times 4 is 8. And then my denominator is 12. Now, my denominator is 12, stays the same, and I just subtract straight across. My answer is 1/12. All right. I want you to take a shot at this page all by yourself. No cheating, no calculators. Ready? Pause. Welcome back. Let's check your work. Switch to a red pen so it's easy for you to spot what you got right and what you did wrong. 9 times 1 is 9. 9 times 3 is 27. So 7, carry the 2. 9 times 8 is 72, plus 2, 74. 6 times, bring down the 0. 6 times 1 is 6. 6 times 3 is 18. Carry the 1. 6 times 8 is 48, plus the 1, 49. That's 9, 13, 8 plus 5, that's going to be another 13. Carry the 1, that's 8 now. So that's going to be 17, carry the 1, 57,339. Ready? Cancel the same side, so you should have been able to cancel this out. Bada boom, bada bang, that's 4. That's 5, so final answer is going to be 4/5. And you are done. For this one, you cannot cross cancel, we cross multiply. And the key to multiplying is actually not multiplying. Remember, you were not supposed to be cheating and using a calculator there. Do not cheat and use calculators right now. The key to multiplying is not multiplying, it's factoring. So we're just going to divide by 12 here. 12 goes into 36 3 times. Therefore, 3 times 3 is 9 equals x, and we are done. Look, Mom, no calculator. Dividing fractions, same thing as multiplying by the reciprocal. So I have 8/21 times, and you simply flip this. 14/64 equals, we're on one side of the equal sign, so we can cancel to our heart's content. 8 goes in there 8 times. 7 goes in there twice, goes in here 3 times. And then we multiply straight across, and that's going to be a 2 over multiply straight across, and that is 24, and we can still reduce that 1/12. Here, I know 2 and 9 goes into 18 evenly, both of them, so I do arrow in, arrow out. 9 goes into 18 twice. 2 times 5, that's 10 over 18, minus, arrow in, arrow out. 2 goes into 18, 9 times, a little 9 there. 9 times 1, that's going to be 9 over 18. And then I simply subtract 10 minus 9, that's 1 over 18, and you are done. Okay, so the first one was computational math. Next one is solving for a variable. Solving for a variable. And there's 3 things you have to be able to do. You need to be able to just follow PEMDAS and solve for a variable. Yes, you actually need to be comfortable with fractions and variables. I'll give you some tricks of the trade there. And you need to be able to what's called isolate a variable. So I'm going to do all 3 here. So in solving for variables, we're following PEMDAS, parentheses, exponents, multiplication, addition, subtraction. When we work with parentheses, I like to circle what you're distributing and always just with arrows. So circle what you're distributing and draw your distributive arrows. Also get in the habit, especially you stronger auditory students, mumble yourself through these computations. Mumble yourself through these computations. Let me model. Negative That's basically 1 times k, that's negative 1 k, plus negative 1 times positive 6 is going to give me negative 6, plus positive 8 times k, that's 8k, positive 8 times positive 3 is 24. And when you collect like terms, well, I don't want you to collect like terms until the next step. Okay, now when you collect like terms, physically collect your variables by circling or boxing, whatever notation, and like underline your numbers, but be physical as you collect stuff. Use circles, boxes, underline. So I have negative 1 plus negative 1k plus 8k, that's 7k. Negative 6 plus 24, that's basically 24 minus 6, that's positive 18, equals 5k plus 5k is 10k. Variables to one side, numbers to the other. Box and label your answers. So circle your distributives when you do them, please. Collect like terms physically using some sort of notation like underlining, boxing, circling. All right, most of you are pretty comfortable with that. And many of you, if I toss fractions at you, it's freak out time. Do not freak out. All right, all you got to do, we're going to solve for this, is we're going to transpose everything by using arrow in, arrow out. Now watch how I do this. Let's first take a look at your variables. We have a 2 here, a 6, and a 4, and you ask yourself, what would all of those go into? One number, big bracket around. 12. Ready? Now, we're solving for this variable. What we're going to do is just get rid of all the fractions right off the bat. It's called equivalent whole numbers, and we're going to do that by doing arrow in, arrow out. Go, work with me here, real slow. 2 goes into 12 6 times. Arrow in, arrow out. Little baby 6 there. 6 times 3, 18, and we have an X there. Plus, arrow in, arrow out. 6 goes into 12 twice. Arrow out, little baby 2 there. 2 times 3 is 6. Now, these parentheses, because it's like multiplication, I don't even have to touch those, because I already got rid of the 6, so I just leave the parentheses. The parentheses remain untouched. Equals, and make sure you do the other side as well. Arrow in, arrow out. 4 goes into 12 3 times. Arrow out, put little baby 3 there, and now we're doing 3 times 24. Do this longhand. Get your hand off that calculator for single-digit multiplication. Do not be in the habit of using your calculator. That's 12. Carry the 1. That's 6. That's 72. Okay, goodbye fractions. Now, most of you are totally okay with whole numbers, so that's how you can get rid of fractions using arrow in, arrow out. Now we're back to solving for the variable. So I'm going to grab that 6 and distribute. Physically collect like terms. Show your work each step. That's 6, 9, divide by 24, And I know 24 goes into 96 4 times. Okay, so working with fractions, the easiest way to work with fractions and solving for a variable is get rid of the fractions by doing arrow in, arrow out with the lowest common denominator. Now, another thing you have to be able to do is isolate a variable. So you're not actually solving, you're just getting a variable by itself. And a very common example of this is you're starting to graph lines and you have an equation of a line in standard form, 4x minus 12y equals 36. And to graph this, it's actually easier if you just get y by itself. So I'm going to give you a storyline. If this storyline doesn't work for you, totally ignore it. Some students it works. Your goal is to get y all by itself. Now, here's my storyline. Pretend y is a guy on a date, and his date is girl 12. And then we have another double date over here. We have 4 and x, another date. And we have that room over here. The equal sign separates two rooms. We're at a party, and then there's 36 on the other side. Now, y gets an attitude. When y gets an attitude, everybody in the room wants to get away from y. Okay, y has a bad attitude. This party stinks, the music's bad, don't like the food, don't know anybody, whatever it is, bad attitude. So everybody wants to get away from y and go in the other rooms. Understand? Okay, so you think who leaves the room first? It's not going to be the date. The date's going to try to stay there. Oh, honey, please, I'm all dressed up. Let's stay. So the date doesn't go first. The other couple leaves first. So we're going to minus 4x minus 4x. So we have negative 12y equals 36 minus 4x. Okay? Again, y still has a bad attitude. This is a terrible party, whatever it is, okay? So now the date, she's going to finally leave. Okay, so girl 12 is leaving her date, boy y. Now, warning, gentlemen, you ever ditch a girl, she's going to go over into the other room and gossip to everyone. That's ladies, we love to chit-chat and tell how terrible our dates were. Warning, guys, that's tongue-in-cheek, I know, but it's partially true. So do you understand? Look here, she's telling everyone. So we take that 12 to every term. Goodbye. So now we have y equals negative 12 goes into 36, negative 3 times. Negative divided by negative is positive. 4 goes in there 3 times. So it's 1/3 x. Now for graphing a line, most of you are more familiar with it looking like this. Y equals mx plus b, so bring the x first. So y equals 1/3 x minus 3. That's called isolating a variable. You want to retell that storyline, I'll do it again in class. If that storyline confused the daylights out of you, just get y by himself. All right, this page is yours. Whoops. Yeah, that page is, no, that page was mine. This page is yours. Pause the video. Welcome back. Get out your red pens, please. Please correct in red. I want to see what you're doing correct on your own and where you need some help. Let's double check our work here. I'm going to grab my distributive and draw my little distributive lines. Grab that number physically by circling it. Next line reads negative 7x plus 8 times 1 is 8. 8 times negative x is negative 8x. Negative 8x, negative times a negative is a positive. Collect like terms, so I'm going to circle all my x's. Underline all my numbers. Select like terms. Negative 7x minus 8x is negative 15x plus 8. And this is still negative 8x plus 8. All righty, we're going to get our 8's to one side, so I'm going to minus 8, minus 8. Bring this around up here. I'm running out of space. 15x equals negative 8x plus 0. And I do plus 8x plus 8x. And I end up with negative 7x equals 0. We divide by negative 7. And 0 over anything is just a big fat 0. So your x should be a 0 there. All right, so here we want to get rid of the fractions. Do not attempt to add, subtract variables with fractions. Instead, we're going to do arrow in, arrow out. We have a 2, and a 5, and a 2 here. So our lowest common denominator was 10. Arrow in, arrow out. 2 goes into 10 5 times. Bring 5 around. 5 times 1 is 5. So I have 5y minus, arrow in, arrow out. 5 goes into 10 twice. Bring around the 2. Minus 2 times 9 is 18. Arrow in, arrow out. 2 goes into 10 5 times. Bring it around. 5 times 3, 15. Now you solve. I'm going to add 18 both sides. End up with 5y. Oops, that is negative right there. Double check my signs here. Yes, okay. So that's negative 15 right there, plus 18. So that's going to be positive 3. Divide by 5. We end up with y equals 3/5. And you are done. Taking a look here, isolate y. Y has an attitude, wants to be all by himself. So we're going to isolate the y. We have girl 9 there. We have a double date, so we're going to bring the double date over. So 6x plus 6x. 9y equals negative 27 plus 6x. Finally, the date says, I am tired of this. I am leaving. So she comes over here and she gossips to everybody. And we end up with y equals negative 3 plus, I'm going to reduce this, 2/3 x. Y equals 2/3 x minus 3 is what you are most familiar with. Okay, that's skill number 2, working with variables. Skill number 3 is working with radicals, So the first thing you need to be able to do is simplify a radical. Simplify a radical. And I have 2 methods for this. I call it the going out for a date method and the get out of jail method. The going out for a date method is you just straight up and factor. So I'm going to factor 72 here. I take any 2 numbers. It doesn't matter. So I'm going to take 8 and 9. And you just keep pulling it apart until you get to all prime numbers. Okay, now you're looking just at the leaves. So I'm putting the little yellow. You're looking just here at what I call the leaves. You're not looking at the branches. So 9's a branch, 8's a branch, 4's a branch. See where your eyeballs should be? You look at your leaves and you ask yourself, who has a date? 3 has a date. And when you go out as a couple, a single couple. So only the 3 comes out, like so. 2 has a date, comes out. This 2, no date, stays home, has pizza. These guys, you multiply on the outside, it is 6 root 2. That is the simplification of root 72. There's another way to do this. I call this getting out of jail. The easiest way is to look for your perfect squares. Think of the first 5. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. And you try to find the largest perfect square that goes into this. And I know in this case it's 36. So I go like this. It's going to be 36 times 2. 36 is perfect. There's the storyline. If you are perfect, you get out of jail. But you must have a change of heart. If you are perfect, you get out of jail. But you must have a change of heart. That's the simplification of a radical. Talk yourself through. Take about 20 seconds and re-describe both of these processes to yourself. 20 seconds. I'm going to be quiet. Okay, so simplifying radicals. That's your first skill using radicals. The next one is learning to simplify a radical expression, or adding or subtracting radicals. There's a little bit of a trick to this. Watch carefully. Okay, take a look up here. Let's pretend you want to simplify this expression. We're going to do that by adding like terms. Let's see, we have negative 7z plus 3x plus 8y minus 2x minus 5y plus c. So I'm going to collect like terms. Negative 7z plus 1c is going to be negative 6z. And then I keep going. I'm going to do my x's now. Note I'm using different notations as I collect these. That's 3 minus 2x, so that's going to be plus 1x. And 8 minus 5, that's going to be plus 3y. And we have 3 different variables here, so we are done. That is the final answer. Okay, a key concept you need to understand is that radicals follow the same rules as variables. Let me say that again. Radicals follow the same rule as variables. For example, notice the z here. So if we were to add like terms, we would add similar radicals. So negative 7 root 2 plus basically 1 root 2 is going to be negative 6 root 2. You add like radicals just like you add like variables. So 3 root 5 minus 2 root 5 is going to be 1 root 5. Notice the radicals don't change, just like the variables don't change. Eight root 3 minus 5 root 3. Look really carefully at these. Really carefully. And I want you to take about 15 seconds and verbally talk yourself through how are these related to each other. Talk yourself through it. Go. Okay, so what we've done so far, we have simplified radicals. We have added and subtracted radicals. And the last skill is to multiply and divide radicals. So when you multiply radicals, all you need to remember are these two outies, innies. Think outie and innie belly button. Outie and innie. Ready? Outies. When I talk about outies, and radicals on the outside, the numbers on the outside the radicals, and innies are the numbers inside the radical. Ready? We're going to multiply and simplify. Draw an arrow connecting the outies. It's going to be 3 times 7 root. Now draw an arrow connecting the innies. 3 times 6. Ready? Now we just multiply. We have 21 root 18. You think you're done, but you're not. Because inside that 18, you can still simplify. So let's break it down. So we have a 3 here that gets to go out on a date. So we bring it out. One little 3. And we do 3 times 21. And then this is 2 here has no date, stays home. So 3 root 3 times 7 root 6, the final answer is going to be, after you multiply and simplify, 63 root 2. I'm going to be quiet for about 15 seconds. I want you to verbally rehearse what happened here. Go. That's multiplying and simplifying. Let's do that again so you can get a feel for it. We're going to multiply and simplify. So I'm going to multiply the outies, and we're going to multiply the innies. And that's going to give us 14 root 75. We're going to break that down. It's 3/4. This 5 here has a date. It's going to come out as a single 5. Cross that out. 5 times 14. 5 times 10 is 50. 5 times 4 is 20. So 50 plus 20, that's going to be 70. Square root 3. Multiply and simplify. Last one is to divide and simplify. And when you divide by radicals, the most important thing is to get rid of that radical in the denominator. I call it the radical in the basement. You don't want those evil radicals in your basement. Those radicals, get them out of your basement. They're going to come up and get you. So we got to get the radical out of the basement. How do we do that? We multiply top and bottom by the exact same radical. Start with that. Ready? So this reads now 5 square root 12 times 2, because it's under the radicals. And then we have 20. Root 2 times root 2 technically is root 4, which is just 2. So we have the 2 down below. That gets rid of the radical. Now, we start factoring where we can. 5 goes into 20 4 times. I'm also going to break down this 12 here. It's called prime factoring. So I have a 3 and a 2, that's 6 times 2 again, that's 12 times that other 2. And then down below, I have this 4 and the 2 again. Now you look in here, who has a date? This 2 has a date, so it gets to come out. The outside, I have a 2 radical. 3 times 2, there's nothing else to pull out, so that's 6 over 4 times 2. Now you can cancel these guys. So our final answer here is going to be root 6 over 4. You're done. Again, I'm going to be quiet for about 15 seconds. I'd like you to verbally rehearse 15 seconds what happened here. Go. Okay, you're going to do these 2 pages on your own, 51 and 52. Do this on your own. Pause the video. Welcome back. Let's see how you did with these. Ready? I'm going to go ahead and break this 54 down, and I know that that's going to be 9 times 6. I keep it going. That's 3 and 3, 2 and 3. I find my dates, and my date is going to be a 3 here. Comes out 3 root 6. And you are done with the answer for that one. 3 root 6. 108, I'm going to break it down this way. I know 36 goes in there 3 times. So here I have 36 times 3. 36 is perfect, so it gets out of jail, has a change of heart. Final answer, 6 root 3. Simplify. The best thing to do is watch out for those radicals and collect like terms. There's one. Get them really carefully. There's another one. And another one. Okay, that's negative 3 plus 8. That's 5 root 2 minus 5 root 2. Guess what? That cancels completely. And then I go to the next one. Root 3. Root 3. I'm going to collect like terms. That's negative 10 minus 12. That's going to be negative 22 root 3. I'm done with that. Last, root 5. Root 5, 6 plus 9, 15, positive, 15, root 5. So the simplification of all of this is simply this. Negative 22 root 3 plus 15 root 5. Or you can write it like this. 15 root 5 minus 22 root 3. That would be also equivalent and perfectly fine. Multiplying and simplifying. Multiply your outies. 2 times 9. Multiply your innies. 6 times 8. I'm going to factor both of these. And I'm going to pull out my dates. I have a pair of 2s. They're going to come out. I have another pair of 2s here. They come out. So 2 times 2 times 2, that's 8 times 9, that's going to be 72 square root, and then this 3 here didn't have a date, so it's 72 root 3. Divide and simplify. We want to get rid of this evil radical 2 in the denominator, so I multiply top and bottom by root 2. And I'm going to bring it over here. I have 6, 24 times 2 over 42 times 2. You simplify where you can. 6 goes into 42 7 times. I'm going to factor, prime factor. That's going to be 2 times 2. That's 4 times 2. That's 8 times 3. That's 24 times my last 2 here, which is 2. And that's going to be over 7 times 2. I pull out my dates. I have a pair of 2s. They're going to come out. I have another pair of 2s. They're going to come out. 3, no date, stays home. Now I can start canceling where I can. I can cancel one set of 2s. Final answer you should have gotten is 2 root 3 over 7. Go back with the red pen. If you got any of these wrong, write yourself little notes about what you need to remember in the future. Write yourself a little note. What do you need to remember in the future?